Okay, number one. At time t in seconds, particles distance is given from a point in centimeters from a point is given in the table. What's the average velocity from 3 to 10? Well, the average velocity is given by the distance traveled divided by the time. And the distance traveled, well, at 10, they're at 144, and at 3, they're at 72. So how far did they travel? 144 minus 72 divided by the time, 10 minus 3. Okay, and so whatever that number is, got my calculator here on the side. I guess I could do this in my head, but it's nicer to use my calculator. I can't do this part in my head, the division. 10.3. Do we have units in here? Centimeters per second. Now notice what this represents. If I were to graph this, and I said 0, 0, 372, 692, 10, 144, it's going to be up here somewhere. This curve might be doing something like this. This quantity, the average rate of change, is the slope from here to here, the slope of that secant line. Okay, so this secant line represents the average rate of change from 3 to 10. Okay, number 3. So we did do, oops, am I writing the right ones down? Yeah, 1 to 19. So 3, find the average velocity for the function 1 to 3 where t is in seconds. So here's my function. So from t equal 1 to t equal 3, the average rate of change is s of 3 minus s of 1 over 3 minus 1, which is natural log of 3 minus natural log of 1 over 2. And the natural log of 1 is 0, so it's a log of 3 over 2. Okay, number 5. Same thing from 1 to 3. So it'll be s of 3 minus s of 1. This is really great notation. So s of 3 is 4. S of 1 is 4 over 3 minus 1, which is, of course, 0. So even though it's moving, the average rate of change is 0. That would be like me, let's see, walking forwards and backwards. If I walk forwards and then turn and walk backwards and calculate my average speed, even though I was moving the whole time, my average speed would be 0, because sometimes I'm walking forwards, sometimes I'm walking backwards. Positive and negatives, and they even themselves out. 7. The average rate of change is s of 3 minus s of 1 over 3 minus 1. So s of 3 is here, s of 1 is here. So s of 3 is 2 minus 2 over 3 minus 1 is 0. And you can actually visually see this. The average rate of change is the slope of that secant line. And lastly, number 9. Bicyclist pedals at a fairly constant rate, evenly spaced intervals of coasting. Sketch the graph of the distance she traveled as a function of time. So what might this look like? So she pedals at a fairly constant rate. So what's happening to her? This is her distance over time. So with spaced intervals of coasting. So I'm going to say if she's pedaling, she's going to be moving away at a constant rate, right? And then she coasts. So what happens when you coast? You start to slow down gently. Oops. I'm saying, so then here, we said evenly spaced periods. So I'm looking at it like pedal away, and then you coast, and you start to slow down. So at this point, your distance, you slow down so your distance doesn't increase as much. So you might go a little bit less, and then you pedal again at the same constant rate. You're going to pick up the same as this down here. And then you coast. Get rid of the stuff here. And you might do this. Now when you coast, this might be curved or it might be fairly straight. But I think it's going to look something sort of like that. Okay? Alrighty, there you go.